My name is Mike Ball. My field is operations research. I have a PhD in operations research from Cornell University. I have undergraduate and master's degree in engineering science from Johns Hopkins. Operations research actually occurs both in engineering schools and business schools. In engineering schools, it's kind of the modern form of industrial engineering. In business schools, it's called management science, and there's a closely related field called operations management. I have a joint appointment in both the ISR and the Smith School of Business here at the University of Maryland. And actually we have a few faculty with joint appointments in the business school and the ISR, and most of them are more like me. We kind of do mathematical modeling, but applied to business problems, manufacturing problems, transportation, etc. I've actually been at the ISR since 1988 and have worked on a broad range of things, including manufacturing problems, network management problems. I actually earlier had an interest in telecommunications and network management, and also manufacturing. But more recently, and when I say recently, I mean in the last 15 years, I've become almost exclusively working in the area of air transportation, specifically air traffic management. In the mid-90s, we competed and won a FAA Center of Excellence in Aviation Operations Research. It originally was a 4-school consortium. It's now an 8-school consortium. So it's called the National Center of Excellence in Aviation Operations Research, or NEXTOR. We work on a kind of a broad range of things. There's faculty from many different departments. If you look over all the schools, aeronautical engineering, civil engineering, business schools, operations research departments in engineering, etc. At Maryland, we involve different faculty from the ISR, but also we have students from civil engineering, from the business school, from applied mathematics, even from economics, and several different engineering disciplines. The project or the kind of research stream we're most known for here at Maryland in NEXTOR is something called collaborative decision making. And it has to do with giving the airlines more control in the process of managing traffic on a day-to-day basis. So rather than the FAA acting as some all-knowing central controller, the idea is to make the whole process of managing air traffic and managing delays more collaborative. So for example, if the FAA were to, say, issue say 100 United flights delays, to the extent possible, you would like to allow United to manipulate those delays so that, for example, the flights that they view as most important or most valuable maybe have less delays. The other flights might have more delays. So, you know, that's kind of a simple statement of it, but as you can imagine, it gets into all sorts of interesting mathematical modeling, optimization, etc. We use concepts from operations research and optimization, but also from economics. We have to deal a lot with modeling equitable allocation problems, etc. Some of the other projects we've been involved in at NEXTOR, as you can imagine, the air traffic system has a lot of uncertainty. For example, a lot of the problems have to do with weather. So we've had a large project funded by NASA which looked at stochastic models for managing air traffic, stochastic optimization models, and other stochastic models. And I think we did a number of innovative things there in how the FAA and the airlines can think about uncertainty in their approach to you know, managing operations on a day-to-day basis. Just to show you the range of things we've done, we also had a large project called the Total Delay Impact Study, which estimated the total economic impact of air transportation delays on the U.S. economy in 2007. This project actually involved all 5, at that time there were 5 next door schools that involved all 5 of the schools, and faculty from all sorts of different disciplines. There actually have been lots of studies that kind of said, well, how many billions of dollars do delays cause in cost to the economy? But we did a lot of interesting fundamental modeling. For example, we did some interesting modeling that looked at kind of the differences in delay statistics of flight delays versus passenger delays. So for example, if you looked at statistics, it says, well, 10 days ago the average flight delay was 15 minutes. In fact, we found that in a fairly reliable kind of rule of thumb is that the average passenger delay was probably a half hour if the average flight delay was 15 minutes. The reason is that, of course, passengers, the reason has to do with so-called disrupted passengers. These are passengers that miss their connections or are scheduled on canceled flights, etc. So there's a relatively small number of these passengers. However, they experience rather extreme delays, and the net effect is that the average passenger delay is actually about double what the average flight delay might indicate. These are just some sort of potpourri of some of the projects we've done at Nextdoor. But as I said, we really work on a very, very broad range of things, from traffic flows to economic impact to even studies of airline safety. So I think it's sort of classic systems engineering in the sense that we involve faculty and students from all sorts of disciplines and have to take a very broad systems look at the air transportation system to accomplish many of our objectives. Thank you.